Okay, welcome to the Unit 1, Lesson 1 on absolute value equations and inequalities. So the first thing we're going to take a look at are absolute value equations. So remember that for any real number x, the absolute value of x is the distance from 0 to x on a number line. So if we put 0 here in the center, and let's talk about the absolute value of 9. Well, the absolute value of 9 is 9, but also if we consider the absolute value of negative 9, we'll also get 9. So if we're looking at negative 9 over here and 9 on this number line, I know that the distance from 0 to negative 9 is 9 units. And I also know that the distance from 0 to positive 9 is also 9 units. And that's kind of the definition of absolute value, right? Distance is always positive, so absolute values, right, will always be greater than or equal to 0. Greater than or equal to 0. All right? So we can kind of generalize that into a statement talking about x units, right? So it doesn't matter what x is. For any value x or negative x, the distance will always be x units. Right? So we can kind of generalize that. And then we can use that to kind of understand absolute value equations, right? So you can read through the equation, the absolute value of x equals p, means that either x equals p or x equals negative p. Notice that you do not change what's inside the absolute value signs. So on this equation here, if we're talking about the absolute value of 5x plus 1, minus 3 equals 4, our first step is to isolate our absolute value. So we can say the absolute value of 5x plus 1 is equal to 7. So that means that if I have a number line, right, I'm looking at either negative 7 or positive 7, right, because it says the absolute value equals 7. So what's inside, right, my 5x plus 1 has to either be 7 or 5x plus 1 has to equal negative 7 because the absolute value is 7, so what's inside is either positive or negative. So we have two actual equations here we can solve. You just go through that like you would any other equation, and you just do it twice. And there's our two possible solutions. So what I would like for you to do now is pause the video and work out number 1. When you're finished working it out, unpause the video and you'll see the answers worked out. So for now, just pause. Okay, so this should be what you get for number 1, either x equals 3 or x equals negative 1. And this should pretty much be a nice review for absolute value equations, which you should have seen and remembered from previous classes. What's going to be kind of new here is we're going to talk about absolute value inequalities. All right? So on an absolute value inequality, we kind of have in the same idea. Like if I say that the absolute value of x equals 9, well then I have two possibilities, right? I have a possibility that x is negative 9, or I have the possibility that x is positive 9. Again, we'll throw a 0 here in the center. But what about the inequality, the absolute value of x is less than 9? Well, again, thinking that absolute value is the distance from 0, where is the distance 0? If this distance here to here is 9, and from here to here is 9, where would the distance be less than 0? Right here. This is the absolute value of x is less than 9. From here to here. Any value of x between -9 and 9 will give me an absolute value of less than 9. So what about the possibility that the absolute value of x is greater than 9? Well, if I'm thinking about that, the distance bigger than 9 is in this direction. So this would be x, the absolute value of x is greater than 9. But what about these values over here on this side? Again, for example, 10 is greater than 9. Right? These distances would be 10 from 0. So this is also the absolute value of x is greater than 9. But if I was to write this as an inequality, I would have to switch this, right? This red arrow indicates that x is less than -9. So notice when you switch from the absolute value greater than 9, right here at this step, and you go down to this step, you have to switch the inequality sign to less than. But over here, if I'm talking about this step, I switch it to just x, it's still greater than +9. So you're only switching the sign when you switch from positive to negative. All right? Let's take a look at a couple examples here. In this case, we're talking about less than, right? And which we'll call and. Anytime you get a less than, it's going to be an and statement. All right? So the distance, again, is going to be between 11 and -11 because it's less than. It's going to be kind of in here in the middle. So in these types of situations, you can write it as a compound inequality. And then you can solve all this at once, right? We'll just subtract 3 from all 3 sections. So -14 is less than 2x, which is less than 8. And then divide everything by 2. And we get -7 is less than x, which is less than 4. And if we wanted to draw that, move this down a little bit, on our number line, right? Here's -7, and here's 4. Our x values are somewhere between -7 and 4. So again, the less than symbol in our original problem ended up giving us the values in the middle. But over here, where we have -11 and 11, we want the distances to be greater than. So we're talking about out here, in this region out here, this region out here. So there's 2 separate regions, so we're going to write 2 separate problems. 5 minus 2x is greater than 11, or 5 minus 2x is less than -11. And then we'll solve each problem separately. Now I'm dividing by a -2 here, so remember when you divide by a negative, you always have to switch the sign in inequality. So I get x is less than -3 minus 5. So -2x is less than -16. Dividing again by a negative. So x is going to be greater than +8. So if we're thinking about, and again this is an or, right? So if I put these numbers on my number line, let's put the -3 here and the 8 here. If x is less than -3, it'll be going in this direction. And if x is greater than 8, it'll be going in this direction. So again, that's a nice little check to make sure that you're solving the inequality correctly, because a greater than symbol should indicate that you're going to have two different regions. All right? The last thing we're going to talk about here is called interval notation. An interval notation is just a shorthand method for writing a solution set between a starting point and ending point. All right. So the key thing here is to realize a little bit of notation, right? If you can either do interval notation with parentheses, right? So if you see a parenthesis, that means that the value, the starting point or ending point, depending on which side of the interval notation the parentheses exists, is not included, right? It's not an actual value that would give you a true statement. We use parentheses when you have an open circle, which you use open circles when you do less than or greater than. The other notation you can use in interval notation would be a bracket. So if you see a bracket, which is more with straight lines and corners, right? If you use a bracket, that means that the value is included. If you use that, you will get something that is true. The other notation that would indicate that it should be a bracket would be a closed circle. And closed circles are used for less than or equal to, or greater than or equal to. So we're going to do a couple examples here. The first one I'm going to give you has a closed circle at 3 and an open circle at 7, and I want the values between 3 and 7. So if I was to write this in interval notation, because it's a closed circle here, it would be a bracket 3, and then I would use a comma, and the 7 is an open circle, so that would be a parenthesis. The second one I'm going to have here also uses 3 and 7. This time I'll put an open circle at the 3 going towards the less than side, and a closed circle at the 7 going to the greater than side. So interval notation, I actually have two separate graphs here, so I'm going to write two separate intervals. The first interval, since it's an arrow here, I would use negative infinity, because it's going towards the left. And then it stops at 3. Since 3 is an open circle, it'd be a parenthesis as well. Then I would have a union to indicate that there's two parts to my graph. 7 is a closed circle, so I would use a bracket. 7, and to indicate the arrow here, I would use a positive infinity to go towards the right. And infinity is because you'll never get to infinity. It's never included, will always be a parenthesis. So with that in mind, you should be able to go up and write these two graphs using interval notation, write the solution set. So pause the video, and then I'll come back after a second and show you the correct solution. Pause the video now. Okay, so here's the two solution sets for our inequalities written out in interval notation. Hopefully you got those correct. And that's the video lesson for 1, absolute value equations and inequalities. So when you get to class next time, we will have some classwork, we'll answer questions, and hopefully clarify any misconceptions or problems you're having, and then we'll practice. All right, have a good day. We'll see you in class.